Good morning, good afternoon, good evening, wherever you're joining us from today. Thank you for joining us for this webinar. My name is Shruti Shivdasan. I am the chair of the SUT Plus Aberdeen branch. And before we start, some of you may be new, some of you may have joined us before, you know the drill. We'll have an introduction to SUT first. So people who are new, the SUT stands for the Society for Underwater Technology. We are a multidisciplinary learned society. We bring together people like yourselves and companies like Orbital Marine together, share knowledge about these topics, anything related to the water, we do something about it. And like I mentioned, I am part of the SUT Plus. The Plus stands for the subset of the SUT for young professionals. We cater to students, graduates, people with a few years experience in the industry, people who are having a career change like myself. And our aim is to increase our members' understanding about the industry. And we do this through webinars like this today, some site visits, STEM events, and we try to give you an insight about the new emerging technology, where the trends are, what's happening in the industry. If you want more details, please check out our website, www.sut.org. And specifically about our Aberdeen branch events, you can check out our LinkedIn page, SUT Plus. We post there regularly, so the most up-to-date information, you'll find it there. If you have any feedback about these sessions, you want to hear about some new topics, please send us an email and we will get back to you. And I think our YouTube channel is a goldmine. We have a wealth of information there. Previous free webinars which have been recorded have been posted there. So just to name a few, we have things on floating solar, hydrogen, offshore wind, subsea umbilicals that you can find there, the previous recordings. And if you've been enjoying these webinars, I would ask you to consider becoming a paid member. This offers you discounts on publications, and it also helps us keep these events free to our members. And if your company and you're looking for some promotion and sponsorship opportunities, we also have that. Please get in touch. Before we start, this presentation is going to be recorded. Kindly mute your microphone during the presentation part and do not share your videos because it eats into the bandwidth. And we have two functions on Zoom. So we have the chat function and the Q&A function. So if you have any questions, kindly ask them using the Q&A function. I'll keep an eye on that. And in the end, in the last 15 minutes, we'll have the Q&A session. And that's when we'll ask these questions to John. Now, my part's done. I shall hand over to John. Kindly tell us more about yourself and the world's most powerful floating tidal turbine.
Thank you very much for your introduction there, Shruti. I'll just share my screen. Okay. Hopefully you can all see that now. So yes, thank you. My name's John Bowman. I'm a mechanical engineer with Orbital Marine Power. I actually went to university up in Aberdeen and started my working career up there, so I know the city well. So I hope you're all treating it better than I treated it when I was up there as a student. Anyway, on to today's presentation. Thank you for inviting Orbital to talk with us today. I hope you can't see that down there. I'll just get rid of that. Orbital Marine Power are a tidal turbine manufacturing company, or design and manufacturing company. We've been in existence since around 2002. We used to be called Scott Renewable Power, and we went through a name change to Orbital Marine Power about 3 years ago, and then embarked on the journey to design and build the Orbital O2, which is, if this will work, where's it gone? Why is this not working? There we go. Which is this machine here. A few of you may have seen this across social media, but this is the world's most powerful floating tidal turbine. The picture that you see there was taken up in Orkney, where the turbine is moored. It is at the European Marine Energy Centre up in Orkney, which, for those of you that don't know, is up here in some of the fastest tides in the world. So it's the perfect proving ground for our device and many other devices of a similar nature. which are installed up there and are subject to some of the harshest tides and weather systems and winds and occasional snow and whatnot through there. So we've been installed there now since last July, roughly. And we have worked through last winter successfully, producing 2 megawatts on a fairly consistent basis. As with all things, there are, sorry, I'm trying to read my notes at the same time. The turbine works as the tide flows past it, back and forth. So it's a fairly consistent output of electricity that you get from a tidal turbine. So we've got just a little video here that I'm going to play about the story of the O2, just to give you a bit more background and share some of the images of the turbine through the manufacturing process and the installation. So I'll just play this and hopefully you can hear it in the background.
We wanted to create a new vision, and were willing to dream of things that never were. We were prepared to challenge conventional thinking, and we wanted to inspire. We just want to do as much as we can to help turn the tide on climate change. It's that simple. Inaction is not an option. The world needs to change to survive, and we want to play a positive part in that. This is just the start.
So that's the story of the O2, the world's most powerful floating tidal turbine. I think the last few shots there really show the power of the tide. The turbine is a stationary element out in the Sound of Ede. And when you look at the images, you can really see the speed of the tide going past. It really is like a fast flowing river past the turbine. And that's why we're able to extract consistent energy. So this is a little bit of the recent history of the company. The first full 2 megawatt power turbine over here on the left of the screen was the SR2000. It was also moored up at EMEC for a year and broke many records for tidal energy production. I believe that in the previous 20 years, I think it is, of all the combined energy production from wave and tidal, that machine generated more in 1 year. So that stands as testament to it, and that was a great proof of concept for then Scott Renewables. So Orbital, then the name change happened, and we went into the design of the O2 turbine, taking lessons learned from the SR2000. And although the power rating is still the same, it's still a 2 megawatt machine, what has changed is that the consistency of the power extraction. So whereas with the SR2000, we peaked at 2 megawatts at the highest point in the tide, stayed there for a wee while, and then it fell away again. The O2 really gets up to the full 2 megawatts very early on in the tidal, as the tide is growing. and stays there continuously through that tide before the tide falls away again and it changes from ebb to flood. So that's where we've been, that's where we are. And then looking to the future, with a very futuristic turbine design there. Who knows where that will lead us, but certainly we're looking at slight developments on the O2 at the moment for future projects. We were very successful recently in the auction round 4 this year, so we're embarking on the build of the turbines that we won through for projects up in Orkney again. And then into the future, we've got other projects that we're looking at both around the UK and wider. Global electricity capacity demand looking to triple, I think it is, by 2050. We want to be a part of that whole package. We're not a single solution, but we are definitely a part of that package as a reliable energy source that we can extract a known quantity over a long period of time. So this is the O2. It has forward and aft moorings off to 4 gravity anchors. The hull is 72 meters long, and we go down to an operating depth of about 26 meters at the tip of the blade. So there's a bit more detail on this next slide. As I say, forward and aft mooring, upper rotor diameter of 20 meters, which allows us to get a total swept area of 628 meters squared. And the thing that kind of makes us unique in the tidal sector is our ability to bring the nacelles to the surface. There are multiple reasons for this, but primarily it means that we can do a lot of the maintenance work that is generally required over the course of the life. Any vessel you've ever been on has always got repair work happening at all times, just small bits here and there, just to keep things ticking over, keep it tidy, keep it neat, making sure that a major fault doesn't occur. And so we have access to that. So why we've chosen it to put a floating device out after many years. As I say, the company started back in 2002. It went through several iterations of device, going from very small to tank testing at universities, through to scale models, which were put out in the sea, working up to the SR2000, which I spoke of before, and then onto the commercial model with the O2. And this has all been on the basis that the highest velocity of the tide is at the surface. So having a floating turbine allows us to have our blades and our nacelles operating in the highest flow state within the tide, which means that we're able to extract the maximum velocity or the maximum energy out of that tide, which increases the turbine yield. The other option, other thing that I alluded to just a moment ago, is the cost to repair. You'll see, or I think you saw in the video at the start, the vessel that towed the O2 to Orkney was just a small multi-cat vessel. These are very common vessels around the UK, and are sort of just a workboat. We were able to pull that all the way up to Orkney over the course of, I think it was about 24 hours, just over 24 hours at that vessel, and have it installed using the same vessel. So that was a huge cost saving for installation. And then, as I said, we can go out with a small vessel to do maintenance on it. And that leads us quite nicely onto this little video, which is our new video for the operations team. So I'll let you enjoy. as it says there, tide and time used wisely. Faults can occur at any time. You never know what it is, but they tend, on the whole, to be minor things. And so being able to go out on a small craft, a small rib, as you saw there, with your toolbox and go out, interrupt the generation for a very small period of time, make that fix, and then get back to generating again very quickly is key to the long-term ability of the turbine to generate and hit the targets that's necessary to fill the void and fill the energy gap that we need to fill. So staying online for a more reliable amount of time is a very big bonus to us. I'll just highlight, you may have seen on the video, there's quite a bit of marine growth on it, but the turbine's been in the water for a year now. I think it's in pretty good shape for the storms that it's been through. Certainly we've not had any real issues going through the storms and stuff, and the marine growth tends to get cleaned off quite nicely just because of the high tidal flows, but there's still a wee bit there that you may have seen in the video there. This picture here, which you may have noticed in the first video that I showed you, is the turbine at the build site at Dundee Port. And this kind of highlights the fact that the industry that is required to actually manufacture these turbines is still in existence in the UK. The overall turbine itself, I think over 90% of the components and materials were built and made in the UK. The ports are around the UK that used to do a lot of shipbuilding, and the skill sets that are required are still very much prominent in the industry as well. So actually being able to go to a place like Dundee Port, which the turbine was actually on a part of the port that used to be called the Caldon shipyard, and we were able to build the turbine there. Now, due to changes in the port, as you'll see there, it looks like it's going over a building site, and technically it was. They were making a laydown area or a marshalling yard for offshore wind while we were building the turbine. And so we had to have a path cleared for us to navigate down to the shore so that we could continue our commissioning. But going back to the fact that the turbine has been built by, industry across the UK. I think this image here shows the sheer variety of companies that have been involved in building it. We've got Fawn Trackway down in Anglesey that did anchors for us, and we've got Gray Fabrication in Fife that made the hull structure for us. Texo in Dundee that was at Dundee Port there that put everything together. ETA that did some electrical work. It's a huge collective group of companies and a UK supply chain which we're still working with as we're going forward to try and make the product better and streamline the process of building the turbine for when we eventually start going into mass production of the turbine and following generations. It also highlights the need for these skills to be retained in the UK. There, as you all know, up in Aberdeen, the skill set up there for oil and gas is phenomenal. And the skills that are required to move across into the tidal industry are very similar. We're able to draw upon the same engineering, the same fabrication work, and a lot of the same companies that are supplying oil and gas are able to transition straight across. So it's a really good way to move some industry across is moving into the tidal sector. This is just a short video of the manufacturing process for one of the sections of the hull. This is the retraction section, which allows the legs to come up and down. It was really fun being part of this and actually seeing the whole turbine come together. It's one thing when you're sitting at your computer on a CAD system and you're designing it and you're looking at the minute little details and you forget just how big and complex this is. I'll just play on that one again, because it's quite a short one. And to actually get out into the fabrication yards and work with people, there was a genuine excitement from those working on the turbine I remember speaking to the welders there that it was a bit of a test for them in some of the areas, but they were loving it, because normally that's, you know, they churn out multiples of the same thing, but this was something new, and something that they said to me that they actually had pride in when they were finished with it, because they knew that it was going to for a good purpose. So that was really something to hear at the time. And as I say, the shipyards of old are still there, and we were able to make use of that legacy during the fabrication and the build and assembly and construction of the turbine, and bring those skill sets back to the fore again, right across the UK. So during the build, this was one of the key moments. This was the first time we actuated the legs. It's important as we're going through the entire build system, as most of you will be aware of, is to test at the smallest component level you can. And for us, this happened to be the smallest component level that we could do this test at. This was obviously quite a scary moment. It was bringing together a lot of actuated components, so rams, you had hydraulic power, you had pins, bushings, linkages, tolerances, fabrication tolerances, all coming together just to make sure that these legs would go up and down straight, and that the pressure readings that we were seeing were in alignment with the calculations that we'd done previous to that. And thankfully, first time it went up, it was perfect. So that was absolute testament to the fabrication skills of those involved in the leg design, the hull design, the linkages. So once that test had been completed, we had to move out of the shed because we got too big for it. We used the SPMTs there to move the turbine outside and into the fabrication yard, so that the ends of the legs could be put onto the leg stubs, and the forward and aft cans could be added on as well with circumferential welds. I just wanted to put this image in as well, just to show the sheer size of the blades as well. Most people are familiar with the size of wind turbines and wind turbine blades, and they tend to be really long and quite thin, whereas Tidal is quite short and stubby, but quite a large surface area to extract the most power. And this is down to the difference in density between the water and the air. But I think this is Finlay, who's our blades manager. He designed these blades and worked on them by hand as well when they were going through the fabrication process, and even when they got up to Dundee. But it just shows I think it's quite a nice picture for showing scale there, just to understand that. And this is another one of us going across the construction yard. I don't think you can see it up here, but up just behind this bit up here, there's three of the engineers are stood watching this colossal machine coming towards us, which was quite an entertaining thing to see, because it's not often you get to see something like that. So we headed down to the quayside just to do final commissioning, final checks, making sure that all the torques were right on external bolting, putting over the final hatches over here, attaching the blades. And we did this right at the quayside to make sure that we avoided any danger during the move, reduce the risk there, and also be prepared to go straight into the water and float up to Orkney. So once we got the thumbs up from the commissioning process, it was time for launch. We got one of the most fantastic days I've ever seen in Dundee for the launch day. The water was flat calm, the skies were bright blue. It was absolutely fantastic. And at 8 o'clock in the morning, the turbine started rolling onto the baobab barge there, the boa barge, that's right, and got strapped down and out into the estuary. I remember this was the next morning that it started to sink. Not started to sink. The barge started to lower into the water so that the turbine could float off. And there was just a car park just over to the left here that's got a wee coffee stop in it, and they'd seen the turbine floating out the day before. And we went across to see this moment from that car park, so we got a different view. and they thought there was an international incident going on because they'd watched this fantastic thing that they didn't understand what it was, thinking it was some sort of plane going out into the Tay, and then when they came to work the next day, it looked like it had sunk. But it was a fantastic day. The float off went remarkably well. I think to quote our hydrodynamicist, when we sent him pictures and videos of how it was sitting in the water, and he's a hard man to please, and he said he was in love with the turbine because it was exactly in alignment with his models. So can't give it higher praise than that, I don't think, from our end. And as I said before, then it was off to Orkney, towed by the small multicat vessel there, all the way from the port of Dundee up to the operations base up in Orkney and Deer Sound, and then from there on to the Falls of Warness, where it's moored for operational purposes. Obviously, we managed to attract quite a bit of attention in the international press. Front page news in many different places, BBC, CNBC across America. And we also managed to attract some royal visitors just after we made it to Orkney as well. The Scapa whiskey that's being poured there by Andrew is part of our sort of blessing of the blades as we did it. Before the launch, we all threw some whiskey over the blades as a sign of good luck for the turbine. And we asked if Kate and William would do the same, and thankfully they said so. They said yes to that, and they were part of that tradition as well. So it was nice. And yeah, that is the story of the O2. So maybe a little short on my time there, but that is where we are at just now. The future is looking very bright for us. The turbine itself, as I said, has been operating very consistently, and we're recently, with the high tides that we've had with the Sturgeon Moon recently, we were breaking power generation records pretty much every week. So it's been a very successful year over the last year while we've been installed. We have learned a lot. I personally have learned a lot. The environment that the turbine is situated in, it's moored in, is very harsh. And the turbine itself has to go through a lot with all the storms that roll through, but the actual force of the tide is the main force that puts the biggest strain on the machine, and obviously it's designed to cope with that. So we're very happy with the performance of the machine, and it's definitely given us a fantastic grounding to move forward into the next generation, and to be able to fulfill the projects that we've now got lined up through AR4 and hopefully beyond that as well. It's a fantastic thing to be involved in. You know, something like this started off as just an idea in somebody's head, 20 years ago. And it may seem like it's taken a long time to get to this point, but it's a very well thought out design. There's been a lot of hard work gone into it, and I think we've seen other technologies come and go in this sector because it is such a harsh environment. It's a very hard place to install something long term, to be able to maintain it at a cost-effective manner, and to be generating on a regular basis. And we've managed to design something and prove that this technology is a match for all those challenges. And we can only build on that progress going forward, which we are definitely looking forward to. So I shall finish there, and I'll pass over to our Q&A and see what comes of that. But thank you very much for listening.
Thank you.